Hi all the students of Narayana 9th standard. Today here I am in front of you all to discuss the work power energy assignment number 12. Okay, let us go with the first question. The first question which is given for you all in your assignment number 12 is n springs, each of spring constant is given as k, are connected in series. They are given and they are connected in series, then the equivalent spring constant is. The equivalent spring constant, if you want to know the equivalent spring constant over here, you have to know the formula. First of all, they are connected in series. What is the formula of series? Formula of series is 1 by k 1 by k resultant. So the resultant is going to be equal to their equivalent spring constant is they are asking. So they are n springs, they are telling they are n springs. Now when you want to talk about n springs, you will be talking like 1 by k plus 1 by k plus so on n by k. So the total sum of the series is going to be n by k 1 by kr. Kr is your resultant what do you say, resultant spring constant. That means all the springs are like this: first spring, second spring, so on, n springs. Now there are n number of springs, right? So what happens to the spring constant, to the resultant spring constant? If anyone asks you this type of questions, then you can find out the resultant as the resultant of the total all the springs is going to be resultant spring constant, force constant. Then how much it is going to be is going to be equal to k by n. So which option it is? Option number 2. Let us go with the next question. Next question is your second question. Second one, right? Let me put it a little up. Yeah, yes. Now a block of mass 2 kg is on a smooth horizontal surface. Okay, we'll draw the diagram. This is a smooth surface. Smooth surface we'll take. This is a smooth surface, and you have 2 kg of block of mass m. 2 kg. It is on a smooth horizontal surface. We don't have a headache of friction over here. Light spring of force constant is, let us take that a spring is connected to a vertical wall, it seems. They gave it over there, vertical wall. Okay, light spring of force constant. The constant of this is given, k is equals to 800 Newton by meter. Newton by meter. Has one end rigid attached to a vertical wall and lying on the horizontal surface. This is lying on the horizontal surface. This is the surface. Now the block is moving towards the wall. That means someone is pushing it from this side and this block is moving towards that side, and this is getting compressed. Now when this gets compressed, what happens? Lying on the horizontal surface, now the block is moving towards the wall, compressed. The spring over a distance of 5 centimeters. It got compressed for how much distance? Up to 5 centimeters it got compressed. Now let us take that compressed distance as 5 centimeters. Okay, and then suddenly they released it. The time the spring regains its energy, regains its natural length, that means after leaving it came back and loses the contact from the block. This one just left over, that means it lost its contact from the block, and the time the spring regains its natural length, less contact with the block, the velocity acquired by the block will be. Now how do you get the relation for this spring constant force and the energy over there? See, if you want to get the velocity over there, you can concentrate on the energy, how much the spring or in this particular situation has happened. Now we'll try to combine that. Now when you want to combine that, so the spring constant is going to be like relation half kx square, the work done over here, work done is going to be equal to work done by the spring constant force is going to be work done, so from the relation work done is equals to energy. Here I am going to equate half kx square, work done by the spring force is going to be equal to your kinetic energy, half mv square. Now half gets cancelled, and you will be left over with kx square. K is somewhat around 800, k is given as 800, and your x is nothing but your displacement, which has that spring got compressed, which is of 5 centimeters. 5 centimeters in the sense 5 into 10 power minus 2 whole square, because centi means 10 power minus 2 is equals to mass of that particular block is given as 2, and we don't know velocity, we have to find it. Now how much you're going to get over here is 800 into your 5 square. If square goes inside, 5 square is 25 into 10 power minus 4, 10 power minus 4, because that square goes inside, it's going to be 10 power minus 4 is equals to 2v square. Now I want velocity over here, so I will target it that side. Now 800 into 25 is going to be somewhat around 20,000, right? So by 10 power minus 4 is nothing but 10,000. So all the zeros goes is equals to 2v square. So from here v square is going to be equals to 2 by 2, which is equals to 1 meter per second. So root 1 is nothing but 1 meter per second. So your option for your velocity is going to be fourth option. Your velocity is 1 meter per second, right? Hope this is helpful for you. Let us go for next question. Next question. Okay, now in this question, this is also a kind of this thing which you have to analyze the situation over here. Let us analyze it. We will try to analyze this question like there is a bolt of mass 0.5 kg falls from the ceiling of an elevator. Let us think we are standing on an elevator, that means it is a lift, and lift you are standing and there is a bolt on top of its head, right? When you have a bolt on top of its head, suddenly that elevator is moving down. It is not a stationary elevator, it is moving down. With what speed it is moving down? It is moving with somewhat 5 centimeters per second. That means elevator is coming down slowly with 5 meter per second, 5 centimeter per second. Then it hits the floor. Okay, then even while the elevator is moving, suddenly that bolt came and fall down from the ceiling of the elevator and fell down onto the floor of the elevator, right? Now the elevator height, if you observe here, elevator height, I am going to draw it. So let us take the elevator. We will draw this situation in somewhat of the different color. There is an elevator, this is an elevator, lift. Let us take, there is a bolt over here. That bolt just came falling down and it touched the ground after some time. Now the elevator height is 5 meters. Elevator is moving down with what speed? With 5 centimeter per second speed. That is speed of the elevator, not the length of the elevator. Length of the elevator is 5 meters. Okay. Now this elevator is coming down. So let us try to find out with how much time it is going to come down. Time is equals to root 2h by g. When you are taking root 2h by g as your time, so how much time did that travel? Like for example, the floor of the elevator of height 5 centimeters they are saying. That means from the ceiling to the floor it is 5 meters, you understood that. But when elevator is coming down, with how much time it is taking to come down, if we try to find out, so root 2, that means you are going to calculate from the ceiling over there, because the object which is moving over there is starting from the ceiling of the elevator, right? Now root over 2 into h is 5 meters by g, you are going to get somewhat around, g is, we will take 10, g will take 10, okay? So 10 by 10 is nothing but 1. So your time is 1 second. The time is 1 second. Now in 1 second the lift has moved for 5 meters. In 1 second distance traveled, 1 second distance traveled is equals to 5 meters. It has traveled 5 meters in 1 second of time period. Now what do? The total distance that bolt has traveled is 5 meters of the length of the lift, and also another 5 meters which the lift has moved down. So the total length over here is 10 meters. The total length that bolt have to travel is the length of the elevator plus that elevator is moving down. Even that length it have to travel. Even that length it have to travel. Right? So let us try to calculate the total length over here. Total length is 10 meters over here. Now what did they ask you? And it didn't get rebounced. After hitting it didn't get rebounced. Now what is the heat produced by the impact? Okay, now what is the heat produced? Heat is an energy. Heat is an energy. Okay, and you have to compare it with the work done. Now heat energy, let us take it as H. I'll use some other different color. Heat is an energy. H is equals to that is an energy, and it is equal to the work done. Now work done by a freely falling body, let us take that mgh as work done. When you take mgh as your work done, so here your m is nothing but how much they gave you, 0.5. Gravity, how much you will be taking is 10 Newton for your convenience. Height, how much did it go? Around somewhat 10 meters. The total height is 10 meters. So H energy, this is heat energy. I'll write it for your convenience as heat. Okay, so into height is 10. So how much you will be getting? 100 into 0.5, which is nothing but equals to 50. Unit of energy is joule. So 50 joules. So heat energy which you have spent over here is 50 joules. So which option it is? Fourth option. Right. So next, let us go for the next question. Fourth question. When you are going into this fourth question, 4 identical springs were connected in series with a spring constant 4 Newton meter. If they are connected in parallel, the resultant spring constant is See, actually when they are connected in series, your question is when they are connected in series. So when they are connected in series, if you want to compare them in series, you have a formula which is 1 by k is going to be equal to, there are 4 identical springs, so 1 by let us take this is ks. Okay, so 1 by k plus 1 by k plus 1 by k plus 1 by k 1 by k, so total 4. Now what happens over here? You will be getting 4 by k, which is 1 by ks. This is in series. Okay, we will take resultant, k resultant. So now if they are in series, so k resultant, actually what is the resultant spring constant? Resultant is also given. Let us substitute that. So the resultant kr is given as 4 Newton by meter. When it is given as 4 Newton by meter, we will substitute it. So 1 by 4 is going to be equal to 4 by k. Now from here, if you want k value, your k value is going to be equal to 16. But see, if it is a single spring, then it is going to be somewhat around 4 Newton meter. But if there are a number of springs, like 4 springs, then the total of their series is going to be 16 Newton meter. So 16 Newton meter. Now they are asking, this is for series. Now they are asking you if they are connected in parallel, how much it would be. If they are connected in parallel, it would be somewhat around K parallel is going to be equal to 4 into K. So what is the K value over there? 4 into 16, which is nothing but equal to 64 Newton by meter. So which option it is? Third option, 64 Newton meter if they are connected in parallel, right? So these 4 springs in series, 16 Newton meter. If they are in parallel, it is around somewhat 64 Newton meter. So it is increasing. Let us go with the next question. Fifth question. Fifth question. A spring of spring constant 8 Newton meter centimeter 8 Newton per centimeter. Newton per centimeter, you have to notice that, has an extension 5 centimeter. So it has got extension 5 centimeters. The minimum work done in joules in increasing the extension from 5 centimeters to 15 centimeters. So when we want to find out these kind of things, we already discussed in previous assignment that a spring constant of 8 Newton meter. So a spring constant is given. So K is equals to 8 Newton by centimeter. It is not Newton meter. If you want to convert it, you will be getting somewhat around 8 into 10 power 2 Newton by meter. 10 power 2, because centi is 10 power minus 2, it is going to be 10 power 2. Has an extension of 5 centimeters. Okay, it got extended to 5 centimeters. The minimum work done in joules in increasing the extension of 5 centimeters to 15 centimeters. You extended it. Actually, it has a fixed value of 5 centimeters only. After 5 centimeters, you displaced it to 15 centimeters. So work done in this case, W is equals to half K x2 square minus x1 square. Right? Now what is your x2 square? I will be writing it like half K is how much? K is 8 into 10 power 2. X2 square is nothing but 15 centimeter square. So I'll write 15. So x2 is going to be equal to 15 centimeters, which I'll be writing it as 15 into 10 power minus 2 meters, which is equal to 0.15 meters. Okay, 0.15 square minus another thing which I have over here is 0.5. okay, 10 power 2, that means, so another one is x1 is equals to 5 centimeter they have given. If I want to convert it into SI, 5 into 10 power minus 2 meters, which is 10 power minus 2 is nothing but 0.05 meters. Now 0.05 whole square, you are going to get somewhat around 0.0225, and this is going to be around 0.0025, right? So is equals to half 8 into 10 power 2, 8 into 10 power 2. So if you subtract this, how much you are going to get? If you subtract it, that is going to be equal to half 8 into 10 power 2. So 0.0225 minus 0.0025 is going to be somewhat around 10 power 2 into 0.02, right? So 0.02, if you subtract it, I guess it is correct. So 10 power 2, and this thing is going to be equals to 8 into 2, 10 power 2 into 0, you are going to get it as 0.02, which 2 gets cancelled, and you are going to get around somewhat 8 joules. So your work done, this is work done, this is also work done. So your work done is 8 joules. Which option it is? Third option. So I hope you all enjoyed this sums, and let us meet in next assignment. Bye.